Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. I'm Courtney, and this is another session of Tutor Me Senpai. Today, we're going to be walking through some 11th grade matrix multiplication. And we're going to be talking about some important things to know about matrices moving forward when dealing with multiplication. So without further ado, let's jump straight in. So our question for today is going to be multiplication between two 2x2 matrices. So this 2x2 matrix is 5, 2, 1, 3, multiplied by this 2x2 matrix, 4, 3, 2, 6. Now it is important to note the size of the matrices you are multiplying because some matrices are not compatible. So you see here we have a 2 by 2. And I did this for a reason, right? And let me show you why. On this side, we also have a 2 by 2. But I'm going to do the reverse here. And that is because these two are important to each other, as well as these two are important to each other. And what I mean by that, these two are important for each other because these will let you know if you can even multiply your matrices. If these are two different numbers, don't even try to multiply them. It's not going to work, right? So this 2 by 2 matrix, how do we know it's a 2 by 2? Well, you're getting this 2 by how many rows you have. You're getting this 2 by how many columns you have. So this 2 says there's 2 rows, and this 2 says there's 2 columns. 2 rows by 2 columns, right? Same thing, 2 rows by 2 columns. So this 2 tells us that if our matrix has 2 columns, the matrix we're multiplying it to needs to have 2 rows. So that's how these two are important to each other. Now these two are important to each other for a completely different reason. So while these let you know if your matrices are compatible, these two will let you know what your end matrix will look like after multiplication is finished. So this tells us that we're going to have a 2 by 2 by 2 matrix when we're finished. So by multiplying two 2 by 2 matrices, we end up, or will end up with, another 2 by 2 matrix. So if this was like, for example, a 3 by 2 matrix, then we would end up with a 3 by 2 matrix. If this was a 2 by 4 matrix, we would end up with a 3 by 4 matrix. So these two numbers let us know if our matrices are compatible. These two numbers let us know what our end matrix will look like after we're done multiplying. So the first step you want to do whenever you're doing matrix multiplication, figure out what type of matrices you are working with. 2 by 2 here, 2 by 2 here. Once we see that these are compatible, let's jump into the actual multiplication. So we've gotten that step out the way. So first step, are they compatible? If yes, multiply. 2 steps. If you're compatible, multiply. If you're not compatible, you can't multiply. So how do we actually do this multiplication? I know you're familiar with multiplying things like 3 times 5, that's 15. However, matrices work a little bit different. Where this would be the same as this. If you multiply, let's say this is matrix A and this is matrix B. If you do matrix A times matrix B equals, let's say, matrix C, this might not be the same as matrix B times matrix A. Okay? And you'll see why once we dive into how we actually multiply. You could end up very easily with a completely different matrix depending on the order in which you multiply. So everything you know about scalar multiplication might not work when we're dealing with matrix multiplication. So how we do this is we're going to focus on rows and columns. So I'm going to put a very big matrix. And we already talked about how our last matrix, our ending matrix, once we finish with this multiplication, will be at 2 by 2. This will also be a 2 by 2 matrix. Now, you don't have to put this here. I'm just breaking this up so you know that it's a 2 by 2 matrix. This here is not necessary. And it's actually not proper matrix notation, but just so you are aware of what I'm doing, I'm breaking this up into a 2 by 2 matrix, just like you would see here. 1, 2, 3, 4 places. 1, 2, 3, 4. Okay? So how you do matrix multiplication is you take your first matrix and you go across. And you take your second matrix and you go down. Right? So you look across for the first matrix and you look down for the second matrix. So by looking across, we see we have a 5 and a 2 for this row. But looking down, we have a 4 and a 2 for this column. So the first thing we're doing when we multiply is go to the first number in our row of the first matrix and multiply it by the first number in our column of the second matrix. Okay? So in this case, the first number in our row of the first matrix is 5. The first number in our column of the second matrix is 4. So it's 5 times 4. And then we're going to add. Okay? So 5 times 4. Let's put it in parentheses just so we keep it separate. Plus. And then we look at the second number in our row multiplied by the second number in our column. So in this case, it's going to be 2 times 2. So put another set of parentheses, 2 times 2. Okay? So that's 5 times 4 plus 2 times 2. 5 times 4 plus 2 times 2. Okay? All right. So that's the first position of our 2 by 2 matrix. Now let's go to this second position down here. We do the same thing. We're going to go across and still go down. Right? Across and still go down. So it's going to be our first number in our second row multiplied by our first number in our first column. So 1 times 4 plus 3 times 2. Our second number in our second row multiplied by our second number in our first row. All right. 1 times 4 plus 3 times 2. Okay? So that's how we get this first column. Now, how do we get this second column? We're going to go back to our 5. And instead of focusing on this column, we're going to focus on this column, doing the same exact thing, going down as we go across on this one. So it's going to be 5, the first number in our row of our first matrix, multiplied by the first number in our column of the second matrix. So 5 times 3 plus 2 times 6. So once again, that's 5 times 3, first number, plus 2 times 6. Second number, second number. And we do the same thing to find this one using our second row. So it's 1 times 3 plus 3 times 6. Okay? So once again, you're always going to go across your first matrix and down your second. You're going to focus on rows at a time for your first matrix and columns at a time for your second matrix. So to find this first one, we do our first row, first column. To find this second place, we do our second row, first column. Because whenever we're multiplying by the first column, we should be only filling in our first column. When we move to our second column, we focus on the second column here. Still multiplying by the same things in our first matrix, but we're focusing now on the second column. Therefore, we can fill in our second column of our end matrix. But everything is the same. First times first, second times second. If there were more, let's say it was a third and a third, you can keep going. 4 and a 4, 5 and a 5. That's why we make sure they're compatible. You have to have just as many columns as you have rows. So we can't end this question with this looking like this. We have to simplify our answers. Okay? So let's do some math to just make sure that everything is simplified. We just want numbers. We don't want equations. We don't want any of this mess here. So let's find out what these actually equal. 5 times 4, that gives us 20. Plus 2 times 2 gives us 4. Then we have 1 times 4 gives us 4. Plus 3 times 2 gives us 6. 5 times 3 gives us 15. Plus 2 times 6 gives us 12. 1 times 3 gives us 3. Plus 3 times 6 gives us 18. Now, let's simplify this even further because we know what 20 plus 4 is. What's 20 plus 4? 24. So I'm going to erase this and just give us the final answer here of 24. All right, how about this one? 4 plus 6. We know what that is. The final answer here is going to be 10. 15 plus 12. We know what that is. The final answer here is going to be 27. And 3 plus 18, we know what that is as well. The final answer here is going to be 21. So remember, I said I only wanted this just to show you how we're going to break this up, but proper notation means that we have to get rid of that. So we have a 2 by 2 matrix, right? We have 2 rows by 2 columns, right? 2 rows by 2 columns. So we got a 2 by 2 matrix. 24, 10, 27, 21. If we look back at our question and the answers that they gave us, do we have this answer as one of our options? Yes, it's B. B gives us the same thing, 24, 10, 27, 21. That means our answer for this question is going to be B. Great job. So that concludes another session of Tutor Me Sempai. Today we walked through 11th grade matrix multiplication. And although we only had one question, I hope it was easy for you to follow along. If you would like more questions in my videos, please leave a comment about that. I'm trying something new to kind of get to the point and maybe break up my videos so it won't be too long so that you can see everything at a click or everything at a glance instead of having to sit through a whole video trying to get to a more complicated example. So I'm going to be trying some shorter videos. If you would like for me to go back to my longer videos, just leave a comment and let me know. Once again, when you're working with matrices, you have to make sure that the matrices you're working with are compatible. You don't want to waste time working on matrices that are not compatible. Pay attention to both your rows and your columns of both your matrices, because they will not only tell you if they're compatible, but will also give you a heads up as to what your end matrix will look like. So if you're doing your multiplication and you don't get what you thought you should as far as your size, something might be wrong. So make sure you're taking the time to find out the sizes of your matrices before you do any work. If this video was helpful, I challenge you to watch it again. Watch it again and keep practicing. Because although matrix multiplication is different from scalar multiplication, it's not that hard once you get it down. But to get it down, you need to practice. Practice and practice. If you would like more videos like this one, why don't you hit the subscribe button? Hit the notification bell so you know exactly when I drop these videos. And leave a like. Leave me a comment. Let me know what you thought about the video. Whatever worked for you and what didn't. I want to try to address anything and everything I can. With that said, I really hope this helps with your homework, and I'm looking forward to seeing you next time. I'm Courtney, and this is another session of Tutor Sempai.